in which what we are doing, we are constructing a difference table. So the difference table is same. So the difference table is same for interpolation and backward interpolation. But if you use forward interpolation formula, so we are using the top values, because the top values will give you the forward differences at y0. Okay, whereas the bottom values will give us the backward differences at y1. Okay, so just for recall, I'd like to quickly write what is the Newton's forward interpolation formula. So what is it? That is f of x equal to, so you may write y0 plus p into delta of y0 plus, this is p into p minus 1 by 2 factorial into delta square of y0 plus p into p minus 1 into p minus 2 by 3 factorial into delta cube of y0 plus and so on. Okay, and here what is p here? P is nothing but x minus x naught by h. Now whereas the backward difference formula, so in the backward difference formula, what is it? That is y0, not y0, we will start with yn, the last value, yn plus p into, if you don't like the same notation p and q here, if you want we can go for q, that's your wish. Okay, okay, let me use q just for to show the difference. Q into nabla of yn plus, and this is q into, this will be q plus 1 by 2 factorial into nabla square of yn plus, and it proceeds that way, q plus 1 and q plus 2 by 3 factorial into nabla cube of yn plus and so on. Where what is q here? Q is nothing but x minus xn divided by h. Okay, so this is Newton's backward interpolation formula, whereas this one is Newton's forward interpolation formula. Okay, now in today's class, let us discuss about Gauss central difference formulas. And yeah, why we are calling the central difference formula? Because we are going to consider the middle values of the table, and the middle value we take it as x0, and the rest of the values we will take it as x minus 1, x plus 1, like that. Okay, so let me show you. So the Gauss central difference formula. So before that, let me show you the table for the Gauss central difference formula. So I hope here you can find a table. All right, so whatever the middle value you have it here, that you consider it as x0. Okay, and above it x minus 1, below it x1. So the index itself we are giving this way. Okay, so it's like the middle is 0, minus 1 here, plus 1 here, minus 2 here, plus 2 here. So this is how we are giving a notation. Okay, so now in the Gauss forward interpolation formulas, we are going to use the central values. Okay, so we make use of the central values instead of the top or bottom. So that is why we call them as a Gauss central difference formulas. Okay, so if you look at the forward difference formula, all right, so this is how it is given by. Because going to the details, it may take more time, so now I'm not going into the details actually. Okay, so I'm presenting you the Gauss forward interpolation formula correctly. And if we compare it, like you can see, it is the p is same as x minus x naught by h. All right, so it is same as p in the Newton's forward interpolation formula, and so the first term is y0 and the second term p into delta y0. All right, so and the next one, what we take here is the coefficient of delta square of y minus 1. and the coefficient is p into p minus 1 by 2 only, 2 factors only. And whereas if it is Newton's forward interpolation formula, the next term is going to have p minus 1, sorry, p minus 2. But here what we will take is, we will take one term on the other side, that is p plus 1. Okay. So you can see it, the first we started with p and p into p minus 1 into delta square of y minus 1. And now it is p into p minus 1 into p plus 1. So it's like from p, first you have gone to minus 1 and then plus 1. And in the next step, what happens? Minus 2, p minus 2 will come into the picture. Alright, and in the next step, p plus 2 also will come into the picture. So that is how we are going to write the coefficients here. Okay. Whereas if you look at the terms here, first one is delta y naught, first one is y naught, second one is delta y naught, and the next one is delta square of y minus 1, and next is delta cube of y minus 1, and this becomes delta cube of y minus 2 on that way. And the next term also delta power 5 of y minus 2. Okay. So this may not be clear just by looking at the formula.
Sir, your voice is not clear, sir.
My voice is not clear?
Sir, it's breaking, sir.
1 minute, I will connect to the other internet. So if you look at the Gauss formula, the given values itself is we index this way, the middle value x naught, x1, x minus 1 and all. Okay. So now if we want to use forward difference, first y naught we will go with the central difference. We will go with the middle one only. That is delta y naught. Okay. So in the next step you will go up. If you write the table in this way, you'll come to know first these two terms will be based on y naught, and the next two terms will be based on minus 1, and next two terms minus 2, and next two terms you can see they will give you minus 3. Okay, and you see the formula here, so which is y naught plus p into delta y naught, that is over. Okay, next the next term will p into p minus 1 by 2 factorial into delta square of y minus 1, and next p plus 1 into p minus 1 into delta cube of y minus 1, so by 3 factorial also. So in the next term, now we will increase p minus 2 here, one more term, and now minus 1 already occurred 2 times, so now minus 2 will occur 2 times. So in the next term, if you see the next term, and the next term is p plus 2 into p plus 1 into p minus 1 into p minus 2, okay, divided by 5 factorial into delta power 5 y minus 2. Okay, so this is how it proceeds. And this formula is useful, let's say if you are asked to compute the values middle to the table. But whatever formula you use, whether it is Newton's forward or backward interpolation or Gauss forward or backward formula, all will give you the same answers. But if the value is near to the middle, the expectation is these terms will be smaller. That is what only we can expect. So that if these are smaller values, then it is easier to compute. So that way only we are going to consider either forward or backward depending upon the asked value. Okay, so here itself let us look at the backward interpolation formula also, Gauss backward interpolation formula. So here, so in the backward, so it is like the first step you take backward, like y naught and p into delta y minus 1 we will take. So instead of moving this way, like earlier what you have done y1, y naught and delta of y naught, this is what we have taken in the forward interpolation. But in the backward interpolation we consider the reverse, that is y naught, and the next term will be delta y minus 1, and the next term will be this one only, delta square y minus 1, delta cube y minus 2, and delta power 4 y minus 2, and delta power 5 y minus 3. So this way it proceeds. Okay, so let me show you the formula. So you can see that y naught here and p into, okay, if you can't see, let me maximize it a little bit. Just for visibility purpose, I'm just maximizing it. Okay, so here you can observe that the first term is y naught and p into delta y minus 1. But when it comes to backward, we will start with p plus 1 first. Like however we do it in Newton's backward interpolation formula, it will be like p into p plus 1. Okay, so p into p plus 1 by 2 factorial into delta square of y minus 1. And next, so now next term p minus 1 will increase and delta cube y minus 2 and delta power 4 y minus 2. Now here onwards you can see them as pairs. Okay, so this is what Gauss backward interpolation formula. Okay, so let's do one thing. So you just make note of these two formulas, forward formula and the Gauss backward formula. Alright, I hope it is easier to keep it in mind, not that difficult. Now let us walk with a problem. So here is a problem. So you're actually given with e power x values for some particular x. So and these xi values are equally spaced. So the first value is 1 and the second value is 1.05. And the difference, if you see the difference between them, the difference, absolute difference is 0.05. Even the next value 1.05 minus 1.10, the absolute difference is 0.05. So all these xi's are equally spaced with the equal distance 0.05. Okay, so since these are equally spaced, okay, we can apply either forward interpolation or backward interpolation, either Gauss or um, Newton's. Okay, remember one thing, these Newton interpolations or Gauss interpolations you can apply only when xi's are equally spaced. If xi's are not equally spaced, these formulas won't work. Remember that. Okay. So if, when they are equally spaced, then only we can apply these formulas, whatever we discussed. Alright, so here anyway it is given. Use Gauss forward formula and try to compute e power 1.17. Okay, so how many values are given here actually? 0, 1, 2, 3, 4, 5, 6. Alright, so the maximum how many differences we can compute? Compute. Maximum we can compute 6 differences. Okay, so first let us do one thing. So they are asking us to find the value of e power 1.17. It means they are asking us to find what is f of 1.17. Okay, it means x value is given. X is 1.17. Alright. So in the formula we know what is p. Now p is nothing but x minus x naught by h. But be careful here when you are using Gauss forward formula. This x naught doesn't mean the first value. X naught is not the first value. Alright. So we need to pick up the middle value. What is the middle value here? This one. Now we give index this way: x1, x minus 1, x minus 2, x minus 3, and this is y1, x1, x2, and x3. Okay, so here x naught, it means it is the middle value. Don't take the initial value. If it is Gauss, only in Newton's x naught, it means it is first. Okay,
Sir, if they given even number of terms, then what we have to take as middle value, sir?
if you are given with even number of terms, yeah, you can have two terms in the middle. All right. So for example, you are
Yes.
given with 1.35 also. Then you can pick up. Then what are the middle terms here? These two are middle terms. Maybe you can pick up one and you can proceed with that. Okay.
Can we pick any among those two, sir?
Yeah. Any among those two you can pick up.
Okay, sir. Thank you, sir.
Because here, whatever formula we are using, it doesn't. I mean, it gives you the same value whether you use forward difference or backward difference. Maybe it may have some rounding errors. That's it.
Okay, sir.
All right. So now, so the middle value here is 1.15. So x naught. So x naught is nothing but 1.15. And how about p? P is equal to x minus x naught divided by h, and that is that is x is so therefore p equal to 1.17 minus x naught 1.15 divided by 0.05. So if we compute everything, I hope we can see that p is equal to this 1 by 4. It means 0.25. Like what they have done here is they have used this formula x equal to x naught plus p into h. Okay, Sam is writing this one. Okay, so we found what is p. Now let us write Gauss forward interpolation formula, and before that let us construct the table. So you take the difference table, you write the values of x and e power x. These are y values. So what is our middle value? This is what x naught. All right, and this is what y naught. Yeah. Now since we are using forward formula, yeah, you come down. So this is delta of y naught. This is what delta of y naught. Yeah, and this is delta square of y naught. Okay, sorry, this is y naught and this is minus 1. Okay, why? Because from the middle one only we are actually going to compute. Yeah, this is delta cube of y minus 1 and this is delta power 4 of y minus 2. Okay, so you do one thing, keep it on paper, take the values, you compute the difference table, and accordingly you pick up the values. All right, now let us write the formula for forward interpolation. So what is the formula? So let me write it here. Gauss forward formula. So that is, I mean, f of x is approximately equal to, now this is y naught plus p into delta y naught plus and p into p minus 1 by 2 factorial into delta square y minus 1 plus p into, okay, let me write in this order only. So p plus 1 into and p into p minus 1 by 3 factorial into delta cube of y minus 1 plus the next terms are uh, p plus 1 into p into p minus 1 into p minus 2 by 4 factorial into delta or 4 y minus 2 plus and so on. Okay, and we know what is y naught. We substituted it here. So directly we want e power 1.17. No, this is what we want, f of 1.17. And if x is 1.17 and you know what is p is nothing but 0.25. Just now we computed it. So in place of p, you're going to substitute what is it? They substitute. Yeah, 2 by 5, and that is anyway 0.2. What is it we get here? 0.4. And what is p value? P is actually, oh, is it correct? Is it equal to 1 by 4? This one, is it correct?
No, sir, it's 2 by 5.
Yeah, just 2 by 5, it is wrong. Yeah, I remember, like at one time,
0.4 వస్తుంది సార్.
huh? Actually, if we compute this guy, yeah, this is 0.02 only, so this is just 2 by 5. Alright, so what they're supposed to write here is 0.4. So that somehow became like 1 by 4. So this is wrong actually. Okay, so that this must be equal to 2 by 5. Alright. So here P is not 0.25, this is actually 0.4. So which is 2 by 5, and here P into P minus 1, and you can substitute what is delta square of y minus 1. You know what is delta square of y minus 1 is here, that is 0.0079. Yeah, so 0.0079 is substituted, and the next value, and anyway the next value is 0, so no need to plug in. So after keeping everything, you can see that e power 1.17 value is approximately this 3.22221. Okay, and we can actually observe one more thing here. This 1.17 is near to the middle value. Okay, and this is near to the middle value. That is why the central difference formula we used it here. All right, and you do one thing, so simply solve the same problem using the backward formula also. All right. So these are what? A Gauss forward and backward formulas, central difference formulas. Okay. So let us stop it here.